Okay, welcome back everyone. In this video I'd like to show you a quick example of how to use Kirchhoff's rules for loops and circuits. So this is from chapter 26. This is problem number 27, and basically we're given all the information you see here, where there's a circuit with a couple resistors and a couple of voltage sources and several loops. And so we're asked to find a couple things. First, we want to know the current traveling through the 3 ohm resistor. We want to know the two voltages E1 and E2, and we want to calculate the resistance R. Okay, so first, how about if we have a quick reminder of what the loop rules are? So from conservation of charge, we know that the current that goes into a junction is equal to the current that comes out of a junction, and it's a sum, so the sum of the currents. Then we know that the sum of the voltages in a loop is equal to 0. So this sort of lays out for us conservation of charge for the first rule and conservation of energy for the second. Okay, so in this particular circuit, you can probably go through and just figure out what all of the different currents have to be just by looking at it. For example, if we start at the top with 2 amps right here, then we're going to have 2 amps right here. And if magically after this junction we have 3 amps going through the 4 ohm resistor, well, that tells us that we have 1 amp which must be going to the left at that point. Okay, which means that we also had 1 amp prior to the power source. Okay, well, we can continue working backwards here, and if we had 2 amps after the resistor R, well, we had 2 amps before it, and now I've got to a place where I have a junction where I have 2 amps going up and 5 amps going down, so it must have been 7 amps going into it. And that 7 amps came from back here, and if we look at this junction, we know that the current that must have been going up through the 3 ohm resistor has to be 8 amps. Another way to see this is that if we have 3 amps on the bottom, we've got 3 amps right here and 5 amps right here. So again, that's going to have to give us 8 amps. Okay, so the current has to be 8. And you can't always figure it out just by inspecting the diagram. Sometimes you can just write a bunch of equations where you look at a junction and you set up variables for unknown currents. And that's not too difficult either. Okay, now we're going to make some loops. So the loop rule says that the sum of voltages in a loop must be equal to 0. So the first loop we're going to do is kind of this top section. Okay? So for the top loop, we can write that the sum of the voltages across the top loop is going to be equal to 0. Okay, so let's start right here at that junction. Okay, we go through the voltage source E1 the normal way. In other words, we go from negative to positive, so it is a positive voltage gain. And then we look, so we went through there, and we come along, and now we're at the resistor. And we don't know the value of this resistor. We will determine it a bit later. But what we do know is that we're going the wrong way through it. So instead of having a voltage drop of IR, remember Ohm's law, instead of having a voltage drop of IR, we're going to have a voltage gain, and since the current is 2, we're just going to write that as 2R. And then we come along here, and now finally we're set to go through the last portion, so the second battery E2. The problem is we're going from plus to minus, so that sign is going to be flipped as well, and that will be minus E2, is going to equal to 0. Okay, now I could have done my loop the other way, so counterclockwise instead of clockwise, and I just would have found exactly the opposite for all my signs, a negative, and a positive. So that doesn't really matter too much. Okay, now let's do the bottom left loop. So that's going to be this one right here. And I'll do that one counterclockwise just for fun. So the sum of voltages on that loop is also 0. And let's do the same thing. Let's start at this junction right here. Okay? And so we're going to have going through E1 the normal way. And then we come down, and we're also going through the 4 ohm resistor the normal way. So that's going to be minus I times R. And then we go through the 3 ohm resistor the normal way. So that's going to be I times R. And this actually tells us directly that E1 is 36 volts. Okay, well that's good. Now let's do another loop for the bottom right. And once again, the sum of the voltages will be equal to 0. And you'll notice that I seem to have 3 unknowns, the 2 E's and R. So you only need to do as many loops as you have unknowns. It's going to be just like in math. If you have 3 unknowns, you need 3 equations to solve for them. And they need to be unique equations. One can't be a multiple of another. Okay, so for fun, I think I decided to go clockwise again. And just for fun, again, we'll start at that same point, and we come up to E2, and we go through it the normal way. That's going to be E2. And then we go through the 6 ohm resistor, and we go through that the normal way. So it's going to be I times R. And then we go through the 3 ohm resistor the normal way. So it's I times R. And that's going to be equal to 0. So our second voltage is going to be, if I can do math, 54. Okay, so 54 volts. And now solving for the resistance is pretty easy, because we know that E1 is 36. We know that E2 is 54. And so what we have is that 2R is equal to 18. So obviously R is 9 ohms. And I'm being really sloppy with my units, but notice that there's no prefixes, there's no micro or nano or anything like that. So as long as we're dealing with amps, volts, and ohms, I can be a little bit sloppy, but you should pay a little bit more attention to the units than I have. But this is really all you need to do. We're done. We found the current, we found the voltages, and we found the resistance. And the key, just to rehash, is to say that at any junction the sum of the currents is a constant. What goes in is equal to what comes out, and the sum of the loop voltages must be 0. Okay, we'll see you next time where we talk a little bit about RC circuits.